This is Geometry, Unit 5, the review for quiz number 1. We're going to find the sum of the measures of the interior angles of a convex octagon. The main things we're looking for here is the concept of sum, interior, the interior angles, and octagon. The convex, all of our figures are convex. We're not working with concave. So that's just kind of an extra word. So the sum of the measures, n minus 2 times 180, gives us the sum of the measures of the interior angles. And since we have an octagon, we know that the n is going to be 8. So 8 minus 2 times 180 gives us 6 times 180, which is 1080. 1080. We're going to find the sum, it's a key word, the measures of the interior angles of a convex polygon. Oh, this one, they give you the actual sum. So we don't know what the number of sides is. So we're going to use the same formula, n minus 2 times 180. I just don't know what n is. I know what the total sum is already. So I'm going to divide by 180. So we have 2,700 divided by 180. That gives us 15. So we have n minus 2 equals 15. That goes in there 15 times. And then we add 2. Give us 17. So the name of the polygon with 17 sides isn't important, but we just call it a 17-gon. You should know the names up through 9, maybe even 10, decagon. But you don't need to know the sides any bigger than that, the polygon names. Each exterior angle, there it is, and they're asking for each, of a regular, meaning all sides and all angles are the same measure. Each exterior angle is 40. So we're going to take the exterior angle formula, and that's what 360 divided by n is. That gives us each exterior angle, because the sum of the exterior angles is always 360. So 360 divided by n. And we know that that equals 40. So we're going to multiply by the n and divide by the 40. And n is going to be 9. And we've learned that that is called a nonagon. A 9-sided polygon is going to have 40 degrees on every exterior angle. Remember, like this picture down here, an exterior angle is formed by extending the side. Find the measure of an interior angle and an exterior angle. So there's two questions here. This is a regular heptagon. So we're going to find the measure of an interior and an exterior. Heptagon is 7 sides. So we're going to say 7 minus 2 times 180 divided by 7. That's going to become 5 times 180 divided by 7. That's 900 divided by 7. And we could call that 7 goes into 9 one time with 2 left over. 7 goes into 20 twice, which is 14 with 6 left over. goes in there 8 times with 4 left over. So that's one way to do it. And 900 divided by 7, another way to think about that is it's approximately 128.57 degrees. This is your exact answer. This is your approximated answer. Now we're supposed to find the exterior angle. Well, there's 2 ways to do that. We could take our angle, our interior, and subtract it from 180 because together the interior and exterior is a linear pair. But if this answer is wrong, then my exterior angle is going to be wrong. So let's calculate and see what we get. 360 divided by 7 equals my exterior angle. 7 goes into that 5 times with 1 left over, goes into that 1 time with 3/7 left over. That's 360 divided by 7 is approximately 51.43 degrees. Together, those add up to 180. These would also add up to 180. So I'm confident with my answers. We're going to find the value of x. First, we have to notice how many sides this has. We also have to notice, are we working with the exterior angles or the interior angles? There are 4 sides. So I know that every quadrilateral has 360 degrees. N minus 2 times 180 would tell me 360. So x plus 2x plus 115 plus 155 has to equal 360. So that's 3x gives us a 0, 7, looks like 270. Divided by 3, my x has to be 9. Nope, sorry. We're grab my calculator. 155 plus 115, that comes out to be 270, and we divide that by 3. 90 just doesn't make sense. What am I missing here? X plus 2x plus 115 plus 155 equals 360. Oh, I'm sorry. See, knowing what a reasonable answer is would be pretty important here. Those add up to 270. It equals 360. I knew that it wasn't 90 because 2 times 90 is 180. That wasn't 180. So we subtract our 270. So 3x equals 90, and divided gives us x is 30. So 2x is going to be 60. For this question, again, interior angles. So we're going to use the formula n minus 2 times 180. It has 5 sides. So 5 minus 2 times 180. 3 times 180 is 540. So I know that all of these measurements have to add up to equal 540. When I add together all my terms that are on the inside, and I subtract my 469, that's going to be 31, so 71. So x would have to be 71 degrees. Now this question is a little bit different. This one gives us exterior angles. We know that the exterior angles, x plus 35 and x plus 15 and 2x minus 20 and 2x, and don't forget this exterior angle, which is of course 90. That has to equal 360 degrees because the exterior angles always add up to 360 degrees. We add our like terms together. We have our 35, our 15, our negative 20 means that we're going to subtract it, and our 90. That adds up to 120. And we have 3 x's. So we'll subtract our 120 to give us 240. Well, this isn't a 3 actually. Sorry. Doing pretty well today. 1, 2, 3, 4, 5, 6. So when I divide by 6, I get x is 40. And that makes more sense. 2 times 40 is 80, and that's pretty close to 80. It's pretty close to 90 looking. So 80 is pretty close to that. Okay. Identify all the relationships we've discussed about a parallelogram. If a parallelogram, then opposite sides congruent. If a parallelogram, then opposite angles congruent. If a parallelogram, what's another one you know of? Consecutive interior angles supplementary. What that means is angles that are next to each other are going to add up to 180. Next to each other are 180. And we also have diagonals. If a parallelogram, then diagonals bisect each other. Oh, we've talked about opposite angles being congruent. Just being sure I hit them all there. All right. So, how are we going to solve for our x? What do we recognize? Are the numbers representing? Are they sides? Are they lengths? Are they opposites? Are they consecutive? If a parallelogram, then consecutive interior angles, are Supplementary. Perhaps the interior wasn't necessary. The consecutive angles are supplementary. So 42 plus 2x has to add up to 180 because they're considered consecutive interior angles. Let's just say consecutive angles are supplementary. That's the way the theorem is written. So we minus 42. 2x equals 138. So we have our 69 for our x. Now we're looking here. We've got to figure out, we have two different things to solve for. We have opposite sides here are parallel and another opposite sides are parallel, so we know we have a parallelogram. If a parallelogram, then opposite sides are congruent. So in that case, x is going to be 4. And we know that opposite angles are congruent. So y has to be 53. Here, I have more room, so I can write the theorem again. If a parallelogram, then opposite angles congruent. So 4 times p plus 3 has to equal 135. Be sure not to set these equal to 180. They're opposite angles. They're not consecutive angles. So we're going to distribute through. We'll subtract the 12. And when we divide by 4, we're going to get a p-value to be 30.75. And you could test that. You could take your 30.75, you could add 3 to it, you could times that by 4, and you got your 135. It's a good way to test it. Check your work. On the opposite side, we're going to find the value of x. That makes this a parallelogram. So for this to be a parallelogram, we know opposite sides are congruent. So we distribute. Subtract the 4x. Subtract the 2. So x is going to be 6. What do we know for this picture? What's happening? What makes it a parallelogram? If this was a parallelogram, then consecutive angles, what about them? Are supplementary. So 21x minus 13 plus 8x plus 19, if they're supplementary, they add up to 180. So here we get 29x and 6. So 29x and 174. And that goes in there 6 times also. Alright, what do you think this one's going to be? If this is a parallelogram, then what's happening in this picture? What about the diagonals? Then diagonals bisect each other. So we know that 6x minus 11 has to equal 9x minus 53. It's not diagonals are congruent, but they bisect each other. If this is a midpoint, for every parallelogram, where the diagonals cross it cuts both segments in half. So you subtract the 6x to get negative 11, 3x minus 53, add the 53, to get 42, x is 14. So for this one, we're going to find the indicated measures of the parallelogram. So we have all these different pieces that we're trying to find. Let's come on over here to the picture and first talk about what we see. We know that diagonals are supposed to bisect each other, so this has to be 4. And if they bisect each other, this has to be 3. This is a 5. If you can't read that, that's a 5. So this side is also 5. The opposite is also 5. The angles. If this is 37, then alternate interior, the zigzag, is 37. If this is 90, then the other two angles add up to 90, because the total has to be 180. So that's going to be 53. And its alternate interior angle is also 53. And these are 90 all the way through here. So let's see how that answers most of our questions. See if we have to find out anything else. So AE, what do you see the value of AE? How about AD? EB? You should be able to answer these before I do. DB. That's 4 plus 4, which is 8. AB is 5. Angle DBA. DBA. 37 degrees. DEC, that has that angle on it, so 90 degrees. The box. ACD, 53. CAB is also there. And what's the perimeter? 5 plus 5 plus 5. In this case, all the sides are exactly the same. So we have a perimeter of 20. Oh, one more. What's the perimeter of triangle AEB? So that's 3 plus 4 plus 5. That's 12. Explain how you know that quadrilateral QRST is a parallelogram. Well, when I look at this, since I have opposite, no, let me change that word because they're not opposite sides, are they? They are diagonals that are bisecting each other. The diagonals are cutting each other into equal pieces. That's how I'm recognizing that this is a parallelogram. What do you notice for letter B? Opposite angles are congruent. Opposite sides are congruent. Two sets of opposite sides. Two sets, and even over here, two sets of opposite angles are congruent. And diagonals that bisect each other, if they're bisecting each other, then it has to be both. Decide whether you are given enough information to determine that the quadrilateral is a parallelogram. Two sets of opposite sides parallel. Yes or no? Does that make a parallelogram? Yes, it does. Two sets of opposite sides congruent. That's our theorem. Two pairs of consecutive sides are congruent. Consecutive sides, no. Two pairs of consecutive angles that are congruent. It would work if they're 90 and 90, but it doesn't have to always be that. Diagonals are congruent. Well, if the diagonals are congruent, we know that diagonals are supposed to bisect each other. So that's definitely yes here. We're going to learn later about diagonals that are congruent. If you're congruent, you could perhaps draw a figure that have the diagonals the same length. So that's going to be no. Four sides are congruent. If you have four sides congruent, then you have two sets of opposite sides congruent. So that's going to be a yes. Consecutive angles are supplementary. Of course, that's our theorem. That's yes. Good luck.